be used to measure atmospheric pressure is called barometer. We have different types of barometer. Pressure. That is the pressure exerted by the gas on the wall, and also each other, the molecules of the gases in the cylinder. And the device that can be used to measure gas pressure is called manometer. We look at few ways by which we can determine the atmospheric pressure and how the gas pressure can also be determined. Then last week we were told that our practical this month, or let me say for February, is practical on electricity. But before we have the practical, we need to have some knowledge. We need to have some knowledge about electricity before practical can be done. So today, I want to walk you through some of the basic things that must be known before you can answer questions. I mean practical questions. Before you can do any practical, what and what must be known? Number one, what is electric current? We need to know what electric current. But before we talk about electric current, which is number one thing you must know, the electricity we are talking about is divided into four branches. Before we come back to this, these are the electricity divided into four branches. These are the branches. The first one is static. Static electricity. Some author they call it electrostatic. Static electricity. Then we have direct current. The second one is direct current electricity. The third one is alternating current. Alternating current electricity. And the milliampere, microampere. Milliampere is 10 raised to minus 3 ampere. Microampere is 10 raised to minus 6 ampere. We should know how solar units can be converted to bigger or big units. Milliampere or a MA is equal to 10 raised to minus 3 ampere. So that's SI unit. 1 ampere can be defined as 1 coulomb. As 1 coulomb per second. 1 coulomb per second. An ampere is defined as 1 coulomb per second. Devices that can be used to measure electric current. How many of us know devices that can be used to measure electric current? What are the devices that can be used to measure electric current? Yes, right. Louder, ammeter. Good. What other instruments can be used? Louder. Devices that can be used to measure electric currents are 1 ampere. There are 3 types of devices that can be used to measure electric current. Here, number 1, we have ammeter. And mostly in laboratory, we are going to use ammeter to measure electric current. The symbol of ammeter is this. You have a circle and capital letter A at the middle. Anywhere you see this, it stands for an ammeter, which can be used to measure electric current. Although there are different types of ammeter too, and we call it range. We have different range of ammeter. That means the range is the lowest deflection to the highest or maximum deflection of the meter. We have 0 to 1 ampere. That means the lowest division is 0 ampere. The highest on that instrument is 1 ampere. Such instrument will be called 0 to 1 ampere. 0 to 1 ammeter. Ampere. 0 to 1 ampere ammeter. We have 0 to 2 ampere ammeter. We have 0 to 5 ampere ammeter. So the lowest deflection to higher deflection of the meter give the range of the meter. The lowest to the highest give the range. But we should know that the range of an ammeter starts from the lowest to the highest. And the symbol, as I said, is this. Now, the ammeter has 2 terminals. Ammeter has 2 terminals. One of the terminals will be red, while the other will be black. The red terminal usually is because they use positive sign on that terminal. That means below or beside the terminal, they put plus. Then the black below or beside the black terminal, they put negative. So we have red positive, black negative. When you want to connect, it means that anytime an ammeter is to be connected, red terminal must be connected to the positive leg of the battery. Red terminals must be connected to positive leg of the battery, while the black terminal must be connected to negative leg of the battery. Please and please take note. When you are connecting, you start your connection from the cell. Cell is known as battery. And battery has two terminals, positive and negative terminal. So the wire from positive terminal enter red of an ammeter. The wire from the negative leg of the battery enter black terminal of the ammeter. Very, very important. When you connect positive to black and negative to red, the ammeter will not be fed. The ammeter will not be fed. The signal you are giving to the ammeter is that you are forcing the contact with the flat to where there is no space. You are forcing the contact with the flat to where there is no space. That's what we call wrong connection. And you damage such instrument. When what is to be connected to positive is connected to negative, it's not like human being. You are forcing somebody to pass through this thing. What you only see is the person standing. No matter how pressure you may apply, that person will not get out of this thing because you are forcing him or her to pass through where there is no entrance. That is when you connect positive to black and negative to red. Such ammeter will not reach anything. So take note of that. Position of ammeter in the circle. Position of ammeter in the circle. Position of ammeter in the circle. I want 4 balls in place and 4 balls. Waste my time. The 4 of them represent each component. This is an ammeter, and they all form a circle. Imagine hand, God no hands. If an hand has to flow through him here, such as can move hand over there, isn't it? Then if I decide to remove an ammeter, what happens? Ground is created. When I remove an ammeter from the circle, what is created? Gap. This is an incomplete circle. Gap is created now because we remove an ammeter. Another way you can look at it is, ammeter is part of the circle. So when the part of the circle is removed, the circuit is incomplete. That is what we say an ammeter is connected in series. This is what we call series arrangement. You are going to have series arrangement on Saturday. This is series arrangement. Now, there is another instrument where the two of you join together. Join hands together. Good. Great. Now, you come. Okay. Okay. You hold it. Hold this thing. Now, look at this arrangement. This arrangement is called parallel arrangement. This arrangement is called parallel arrangement. An instrument will be connected like this. I don't want them to come the second time. That's how I want to do it here. That one is called voltmeter. Voltmeter will always be connected across the circuit. The main circuit are the three of them, and they are in series. Something is connected to one of the back of one of the components. This is now across the whole circuit. If I decide to remove this, this is my voltmeter now. Circuit is not dissolved. The circuit is still complete. So, voltmeter will always be connected across, while ammeter will always be connected in series. So when you remove any of the series, gap will be created. When you remove a component that is connected across, gap is not released. The current can still flow through. When the voltmeter is disconnected, and so somebody is bad, what we are trying to demonstrate is not really catch it. How is the ammeter connected to the circuit? How is it connected? Look, ammeter is always in series with other components. Whereas voltmeter will always be connected in parallel. I will show you that in the circuit. When we get to the circuit, look at this. Now, look at this. What I've just demonstrated for you is simply this. This is one of the students. This is another student. This is another student. This is another student. And they are in series. They are in series. This one is called cells. We call this one cell. We get there. Cell, which is the battery. This one is the E. That's another student. This one itself is an ammeter. And this one is called resistor. So 1, 2, 3, 4. 4 students are already connected. This is their hands. The hand is called connecting wires. The hand they use to join them together, we refer to that one as connecting wire. So the 4 of them are connected here. The 4 of them are connected, as you can see. This is series arrangement. Now, if we decide to remove an ammeter, as I said earlier, I remove the ammeter. Gap is created. This is an incomplete circuit. This is what? An incomplete circuit, because I have removed the ammeter. Now, let's look at this. This one is called the straight line. Connecting wire. You can see 1, 2, 3, 4. There are 4 connecting wires. Connecting 4 components. There are 4 connecting wires. Connecting 4 components. Is that clear? So, look at this. This is from leg. This is positive leg. Positive leg. And this one is negative leg. Obviously, this leg is coming from positive side of the battery. It's coming from positive side of the battery. Enter resistor going out like this. So when you get to the ammeter here, this leg will enter through red of ammeter. Why? Because it is coming from positive leg of the battery. This is negative leg of the battery. Go to the key. From the key, this will enter black. If I want to check your connection, if you have to connect it, I will start from the battery here and check which wire enter positive terminal, which wire enter negative terminal. It's when the positive terminal is connected to positive leg of the battery and the negative terminal is connected to negative leg of the battery. That's when I will now clap for you that your connection is correct. If otherwise, the positive is connected to negative, then you are likely going to damage the ammeter because you are forcing the ammeter to deflect to where there is no space, and the spring of the ammeter will be damaged. Am I communicating? Now, this is series arrangement of ammeter. What do we call parallel arrangement? If you want to connect both meter, we get to that one. Both meter will now be connected across one of the components. And such will now become, it will be this, it may be here, it may be connected across the cell. Both meter may be connected across the cell. Is it that here or here? But what we know is both meter will always be connected in parallel. Can you see the difference now? Can you see? Alright. Now we go to another instrument that can be used, but that has to be converted to an ammeter, and that is galvanometer. Another device that can be used is called galvanometer. The symbol of galvanometer is this. You have capital letter G. Galvanometer is another device that can be used to determine the ammeter. But galvanometer measures very small quantity. Galvanometer measures small quantity of electric current. That's milli or micro. You have to convert that galvanometer to an ammeter. How do we convert galvanometer to an ammeter? Who knows? The process of converting galvanometer to an ammeter is called what? Yes. Louder. Like. What do you mean by shunt? That process is called shunt. So what is shunt now? Louder. Who can say it properly? Well, the process of converting galvanometer to an ammeter is called shunt. And what is shunt? Shunt is simply connecting low resistance resistor in parallel with the galvanometer. Connecting low resistance resistors in parallel with what? A galvanometer. That process is called shunt. So when that is done, you can measure micro quantity of electric current, milliampere or microampere can be measured. Conversion of galvanometer to an ammeter is called shunt. It's called what? It's called what? What is shunt? So another device that can be used to measure electric current, another one is called meter. We call it Mope meter. The Mope meter we are talking about is just like when we say multi-purpose. Mope. Mope means it's a device for instrument that can measure 2 or 3 types of things. Mope meter measures electric current. Mope meter measures potential difference. Mope meter measures resistance. 3 in 1. 3 in 1. That means Mope meter combines ammeter, voltmeter, and ohmmeter together. Ammeters, voltmeters, and ohmmeter together. That's what we call Mope meter. Usually we don't use that in laboratory. But if at all you find it in laboratory, it's your teacher that will use that. It's ammeter that will be given to you if you are doing the practical. And on Saturday, it's ammeter that you will see. But Mope meter, if you want to see, those radio side technicians, they call it meter. So that meter they use, either the radio side, the radio link, or even the stop repairer, clock or wristwatch or whatever. Those people repairing clock. What they use that for? Those one use it to test continuity. They use it to test continuity of the battery. You can use the voltmeter or multimeter to test whether battery is okay or not. We can use multimeter to test the continuity of the wire. Whether wire has damage internally, multimeter will detect it. The multimeter can be used to test the continuity of the wire. You may buy a wire newly, thinking that it is continuous, but when you peel the insulator from the wire, you use one terminal of the multimeter to touch one end and the other end to touch it. You will twist it to continuity. The multimeter will read if the wire is good or if the wire has cut internally. The multimeter will detect it. Multimeter does not have a symbol. So, like the other two I put here, we have multimeter. Multimeter does not have a symbol simply because it stands for ammeter, it can stand for voltmeter, it can stand for ohms meter. That's why it does not have a symbol. So that's the devices that can be used to measure. Just as this one has two terminals, this also has two terminals. You have red and black. It depends on maker. Some maker may not differentiate the color, but they will put the sign there for you so that you know. Any instrument that has black and white, or they put the sign positive and negative, ensure that in connection, connect positive to positive, negative to negative. In other words, positive leg of the battery, you must maintain it. That positive leg, the wire from positive leg of the battery, must enter through red of such instrument, must enter through positive terminal of the instrument, whereas all the negative terminals from the battery, negative from the battery must enter black terminals of the battery. So this is what you ensure when you are connecting in laboratory. You ensure that this is from positive leg connected to the positive of the ammeter, and if you are coming from negative, you connect it to black terminal of the ammeter. Is that clear? How do we generate electric current? How do we generate electric current? Please don't forget the unit. I have said it. And last year, 1 ampere equals 1 coulomb per second. That is the definition. And you can convert that to that. Then, briefly, how do we generate? There are questions like that. Apart from cell factory, you may be asked to mention 2 or 3 other methods by which electric current can be generated. Can you tell us ways by which electric current can be produced or generated? Just let's discuss that so that we can still talk about some other again Saturday. Yes? Yes? Cell? How does it happen in the cell? How does it happen in the cell? Here it was to another thing that we more useful to society. That's what we are doing in science. When we are talking about production of electric current, we get electric current from electrical energy, isn't it? Electric current is obtained from what? So, how do we now get electrical energy? There are so many conversions that can lead to electrical energy. In the case of cell, he was talking about that's conversion of chemical energy. In cell, chemical energy is being converted to electrical energy. And from electrical energy, we have electric current that flows through the circuit. So conversion of chemical energy to, that's the summary of what? Chemical to electrical energy. Aside that, what other conversion of energy will give us electrical energy. There are so many. The one we have at home now, which is common. Generator was common before, but this day we are talking of solar, isn't it? We have generator. That's what we call DC or AC dynamo. Generator converts mechanical what? To what? So when you have gotten electrical energy from mechanical, then current flow from electrical energy you have obtained from from mechanical energy. So generator we have at home simply convert mechanical under electricity. I think 4 branches of electricity I wrote earlier. When we get to magnetism, you are going to see how generator converts mechanical energy into electrical energy through the rotation of what? The conductor. The rotation of the conductor in the magnetic field. Electricity will be induced. When we get to magnetism, if time permits us to discuss that, you are going to see how that is generated. The rotation brings about induced EMF, which generates electric current that we are talking about. In other words, conversion of mechanical energy to electrical is done in a dynamo. And we have 2 types of dynamo. We have DC dynamo and AC dynamo. We have just 2 things that you can use to convert one to the other. And that is the ring. In AC, you have slip ring. Slip. S-L-I-P. Slip ring. That's in AC. But in DC, we have splits. Split, to split things into 2. We have split ring. So if you remove split ring and replace with slip ring, you have changed that DC generator to AC generator. That is the area where they are different. Every other thing remains the same. They have the same thing in common, aside the type of link that give the name to that. But whichever you use, the 2 of them convert mechanical to electrical. So you can generate electric current from mechanical energy through dynamo. Electric current can be generated from chemical energy through cell or battery. Am I communicating? Solar energy can also be converted to electrical energy. Solar is common now. Solar is common. So we use photocell. We have photocell. That's to say the mount on top of the tower or building or roof to trap the solar. So, but what we are talking about is solar can be converted to electrical energy, and from electrical energy, electric current can be produced. We are talking about other way by which you can generate electric current aside chemical. That is, aside using battery. Am I communicating? Turbine generator can be used to generate electric current. Turbine generator can be used to generate electric current. We can use wind. Wind energy can also be converted to electrical. So, and so many other energy that can be converted to electrical energy. So you have it in mind. Apart from battery, we have other ways by which you can generate electric current. So that is that. Now, having known electric current, we can also know that the first term we quickly want to see. Another term you need to know is the potential difference, or we can say electromotive force. We want to look at electromotive force and we also look at potential difference, and I will discuss the other term that's related to that. Let's quickly look at electromotive force. Electromotive force. electromotive force. Electromotive force. Usually we abbreviate it as EMF. Electromotive force is also abbreviated as EMF of a cell. Electromotive force of a cell. Then we look at the cell itself. Electromotive force. What is electromotive force? Who can define electromotive force in the class? What is electromotive force? Yes. Again.
Electromotive force can be divided as the work passing through a circuit per unit quantity of time without giving any point to an open circuit without delivering any point to an external circuit.
You are mixing so many things together. You are mixing so many things together. Okay, let's have it. He has mixed so many things together. Electromotive force, have it down, is the work done. Electromotive force is the work done in moving a unit charge. In moving a unit charge. In moving a unit charge from one point to another in an open circuit. The work done in moving a unit charge from one point to another in an open circuit. In an open circuit. That's one way by which you can define electromotive force. Another way you can please in an exam, don't give two definitions of any physical quantities. Don't give, I've said it before and I'll keep on warning you. If I give you different definitions, when you are writing the exam, don't give the three definitions if the question is asked in the exam. It is dangerous. Why is it dangerous? If one of it is correctly put and the other is not correctly put, it means you have set question for the examiner to pick the right one out of the two. No examiner will accept any of the two. I mean, if one, maybe instead of putting it very well, and it's not properly put, but one is properly put, the examiner will not mark any of the two right for you because you have set question for the teacher. That's number one. Number two, let's even assume that all the two you put them correctly. You wasted the time you ought to have used to answer that question, to answer the same question that will not fetch you additional mark. If you like, give 5 definitions for one quantity in physics. The mark for that question will not be increased. We will thank God for the way they set questions this day, unlike in the past. You can ask for more paper and still score 0 at the end of the day. But this day, they already narrowed the candidate. The little space they want you to put your answer. If you go beyond it, they won't read whatever you put down. And you cannot exhaust that and say, I need more paper. They will ask you, what question do you want to answer to that? But whichever the case may be, when you know 2 or 3 definitions, it is better to master one very well and put that one down in the exam. I said work done in bringing a unit positive charge from one point to another in an open circuit. That's electromotive force. Or you can also define it as electromotive force can be defined as potential difference. Potential difference across the cell. Potential difference across the cell. When the cell is not delivering current, when it is not delivering current to external load, when the cell is not delivering current, that's potential difference across the cell. When the cell is not delivering current to the external circuit or load. That's another way you can define electromotive force. Whichever one you want to pick out of the two. But like you have said, don't take the two. So we use EMF, or simple abbreviation is E, capital letter E, stands for electromotive force. And I mentioned a component called battery. We're going to talk about battery now. So, but before then, the electromotive force, since it is the potential difference across the cell, so we can now have cell being arranged. When we say cell, a cell is a cell. But when you have two or more, then you can talk about how do I arrange them. Then we talk about type of arrangement of a cell. Now, electromotive force is defined that way. There is something closer to electromotive force, and that is potential difference. Please take note. Potential difference. Potential difference. Potential difference. Potential difference usually represented as V. That's potential difference V. Potential difference V. Who wants to define potential difference? Yes, you put up your hands. Anybody? Potential difference? Now, potential difference can be defined as work done. Work done in bringing a unit positive charge. Work done in bringing a unit positive charge from one point to another. From one point to another in a closed circuit. Work done in bringing a unit positive charge from one point to another in a closed circuit. We can also refer to it as external potential difference. Is the potential difference external potential? That's another way. External potential difference is potential difference across the cell. The potential difference across the cell. It is the potential difference across the cell. When the cell is delivering current, to the external load or circuit. What's the difference between potential difference and electromotive force? Is there a difference between them? Can somebody stand up and tell us the difference between the two? The electromotive force and potential difference. I will still give you a term. A term will be given to you, which is similar. Yes, what's the difference? You say yes. What's the difference between potential difference and electromotive force? Who wants to give us that? Are you in class? Is there a difference between electromotive force and potential difference? Yes. What's the difference? Yes. I expect all hands up. We have just said something now and you wrote them down.
Electromotive force, of course, and it is work done removing a unit charge from the open circuit. While the bigger difference is the work done removing a unit charge from one point to another in the closed circuit.
It's tough for me. Actually, what I wanted you to say is that they are different. One is open circuit, the other one is closed circuit. That's all. Every other thing remains the same aside that electromotive force we said na an open circuit. Potential difference we said in a closed circuit. That's just the difference. When you are reading, try to code what you are reading. The second definition I give to you, I said potential difference across the cell when it is not delivering current to the circuit. That's the electromotive force. We are now saying potential difference now will now be potential difference across the cell when the cell is delivering current to the circuit. Is that a big deal? And I ask you, some of you are just looking at it, something you have learned 10 years ago, you have forgotten. That's not good enough. Bro. Now, manufacturer of the cell, we always write the value beside it. The manufacturer of a cell, we always write the value beside it. So, if you connect a circle like this, there are two types of key. Let me use the other key, that will be easier. This is another symbol of the key. As it is now, if I decide to measure EMF, electromotive force across this cell, I will just connect the voltmeter here, as I said earlier. Whatever reading I have here will be EMF because the circuit is open. Key is open. To open means to switch off. To switch off. This key is open. Whatever reading here, if the reading may give me 3 volts, this may give me 3.0 volts because I'm having 2 batteries. Maybe each of them is 1.5, 1.5. The reading here will give me 3.0 volts because it's an open. That's EMF. But if the key is on, that means you close it. You have like this. This is an open circuit. Open circuit. This one is closed. Now, if you read here now, as you close the key, you know current is flowing. This will reach certain value. It's already closed here. The reading on this will now be potential difference. That's represented by capital letter V. Or you can refer to it as external potential difference. The reading this value will give to us will be called potential difference. That's external. So, because the circuit is closed, when the circuit is open, we call that one electromotive force. When the circuit is closed, we call this one external. If this is now called external potential, that means you have another potential called internal. Let me inform you, it is the sum of the two potentials that we call electromotive force. The sum of both external potential difference and internal potential difference that we call electromotive. In other words, I can simply say what then is electromotive force. Electromotive force can be expressed mathematically. Electromotive force can be expressed mathematically as E equals capital letter V plus small letter v, where, please take note, E stands for electromotive force of the battery. So then capital letter V stands for external potential difference. External potential difference. And small letter V stands for internal potential difference. So when we add the two of them together, we get it. You may call this equation 1. So if you now want to know any of these, you make the one you want to know the subject of formula. There are 3 of them. 2 will be given to you. When you know 2, you can get the third one you need. Any 2 can be given, and you get the third one. Any questions on that? Any question? Good. Now, there is another term that is very close. We are talking of potential difference. Is electric potential the same thing as potential difference? Electric potential and potential difference, are they the same? But look at the definition though. They are very similar, but they are not the same. Electric potential is not the same thing as potential difference, but they have the same unit and they have the same instrument we use to measure them. I'm talking of electric potential. Electric potential. If you are to define electric potential, we also represent it as V. It's not the same thing as potential difference, but the same instrument can be used to measure them, the two of them. How do we define potential, electric potential? Please have it down. Electric potential can be defined as the work done. Electric potential can be defined as the work done in bringing the unit positive charge from infinity to a point. From infinity to a point, that's electric potential. Can be tried to say in electric field. We are bringing the unit positive charge from infinity to a point in electric field. So the work done in bringing the unit positive charge from infinity to a point is called electric potential, and it's also measured in volts. We use the same instrument to measure it. Please take note of that. And that is a scalar quantity. So, but that's not where I'm going to. We'll learn more about that under static electricity. I gave you 4 branches of electricity. Under statics, we talk about electric potential and some other under static or electrostatics electricity. We'll learn more about those ones, but they are very similar. Electric potential, potential difference, they are not the same thing. So that's where I'm going to. Now, instrument to measure potential difference or electromotive force. Instrument that can be used to measure electromotive force or potential difference. I've mentioned it. I will not waste time on that any longer. To measure potential difference, you can say electromotive force. To measure electromotive force or potential difference. To measure electromotive force or potential difference. Just as we mentioned earlier for current, we still have 3 of them. There are 3. There are 3 types or devices. They are 1. Voltmeter. We have voltmeter. The symbol of voltmeter is you have capital letter V and you have this. Then 2. The voltmeter, just like we said in the ammeter, it has 2 terminals, black and red. Black for negative and red for positive. Then just like you maintain, the positive must be connected to positive leg of the battery and the negative leg of the battery must be connected to negative of the ammeter. In other words, positive of the battery goes to red, negative of the battery goes to black. So you have these 2. And the position of the voltmeter in the cell is always across. I told you earlier. So Across means when you disconnect voltmeter, the circle is not disturbed. The circle still remains what it is because the voltmeter is connected across. The current will still flow through when the voltmeter is disconnected. So that is that. We can also use galvanometer, but it must be converted to voltmeter before it is used. Galvanometer can measure very small quantity of current, and we can convert that to, very small quantity of potential difference, which can be converted to voltmeter by connecting high resistance resistor in series with galvanometer. Conversion of galvanometer to voltmeter is called multiplier. Multiplier is the process by which a galvanometer is converted to a voltmeter, and this is done by connecting a high resistance resistor. By connecting a high resistance resistor in series with the galvanometer. Connecting high resistance resistor in series with the galvanometer. That simply convert the galvanometer from galvanometer to a voltmeter. And so you can use that to measure potential difference or electromotive force of a given cell or cells. So another one you can use to measure is multimeter. I said that earlier. So the second instrument here is galvanometer. The manometer has the symbol of G, this, but you convert this one to voltmeter. Process is called multiplier. Process of converting galvanometer to a voltmeter is called multiplier. Process of converting galvanometer to an ammeter is called shunt, but to voltmeter is called multiplier. And you can also use the third one, I said it earlier. That you can use multimeter. Multimeter is multi-purpose. Like I said, 3 in 1. It measures electric current, it measures potential difference, it measures resistance. That means it combines ammeter, voltmeter, and ohms meter. That's why we call it multimeter. And that's why it does not have a particular symbol, unlike the other two. So, having known this, we want to look at some of the components. The components that we are going to meet, the components and the arrangement of components in the circuit. What are the components that we meet in? Before we talk about circuit itself, components in electric circuit, or before we talk about the components, we talk about what we call circuits. Then we can now talk about the components in the circuit and how we can connect them in the circuit. What do you understand by electric circuit? What is an electric circuit? Electric circuit, what is it? What is electric circuit? Any idea? I want to believe that most of the things I'm asking you know is only one talk. Because circuit is discussed right from SS1. It can simply be defined as the path taken by electric current from the source through a component, at least one component, and back to the source. That's the simple definition you can give. The path taken by electric current from the source of electric current through the component, at least one component and the key. So we call that electric circuits. The component in direct current electric circuits and their symbols and their symbols. Let's have a kind of table. Here you have it like this. Kind of table you have here. The first one, the first column is serial number. Serial number. Number 1. The first one is cell. Cell. That's components. Direct current electric circuits and their symbol. And their symbols. You have like this. Serial number. You have components. You have symbols, then you have their position. Number 1, we have cell. The symbol of a cell. You have this, one long and one short plate. The long one can be positive, this is negative. That's the symbol. And the position can be either series or parallel. You can have series, this can either be in series or parallel. You can have it in series and you can have it in parallel. That is a cell. Of course, it's different from capacitor. The case of capacitor, the two parallel are having equal size, equal height. This one is capacitor. We refer to this as capacitor. So when you want to show the symbol of cell, you have to be careful. Make sure that one is longer than the other. And when you have to show the symbol of capacitor, don't be too fast or otherwise to make one of these longer than the other. Do you know? Look at this. If you write like this, the examiner will take it to be cell because it's obvious that this is longer than this. If one of the plates is longer than the other, it's no more capacitor. It is a cell. The rule is that the symbol of a cell, one plate must be longer than the other. The longer one is positive while the short one is negative. But we want to show the symbol of a capacitor. The two legs, the two plates must have equal length or equal height. So please take note of that. Then you write on top of this, E will always be rated. E stands for electromotive force. If there are two cells, two or more cells, then we talk about equivalent or total electromotive force, E total. That is when you have more than one cell in the circuit. Then you write, instead of this, let's say you have a cell like this, another cell like this. These are two cells. So you combine the two of them together You combine the two of them together to have E total across the two of them. That means E1, E2, combine them together will give you E total. But the symbol of cell is this. Then, number 2. The second one is connecting wire. Connecting wire. Connecting wires. It's just a straight line. A straight line like this. It's a symbol of a connecting wire. When I draw a straight line, does not mean that connecting wire cannot be bent like this. This is still a wire that is curved. This is still a connecting wire. So when you see this, it's a connecting wire which may be either in series or in parallel position with other components. It can be in series with other components. It can be in parallel. Number 3 component that we meet in the circuit. Number 3, and that is the key. As I said earlier, we call it key. But a layman, we call it switch. A layman, we call it switch. To on and off the circuit. To on the circuit, to off the circuit. The layman call it switch. But in lab, we call it key. The key has 2 symbols. The key has 2 symbols. The first symbol may be this, 2 brackets with K on top. That's a symbol. Or you have another one. Another symbol can be this. You have this, open like this, and put K. In any of these one, this or this can serve as key. That's the switch you come across in the circuit. That is what will come across in the circuit. Key. Then number 4, component you see meet in the circuit. Aside this are resistors. You have resistors. Number 4. A resistor has the symbol of key, can also be in series or parallel. That's its position in with other. Now resistor has the symbol of this. This is symbol, a resistor of symbol. The computer symbol. This has old symbol. Old symbol of a resistor is this. You have like this. That's resistor. Old symbol. Old symbol. The old symbol of a resistor is this. The new symbol of a resistor is this. And this resistor is a fixed resistor. Fixed or standard resistor. This is the fixed. You can put this one as fixed or standard. Standard resistor. Fixed or standard resistor has this symbol, and it may be arranged in series or parallel. When we say fixed resistor, a resistor that is fixed has a value written on it that cannot be adjusted. The value on this resistor cannot be changed. If manufacturer put 2 ohms, you can reduce it to 1. I cannot increase it to 3. Not even 2.5 or 1.5. It is fixed. It is standard. You make use of it where 2 is needed. There is nothing you can do to that. Or any other value. Once it is a fixed resistor, we make use of the value we put beside it. You can't change it. That's why we call it standard or fixed resistor. The symbol of standard or fixed resistor is what you see. You come across it in the circuit. Then another one is variable resistor. And there are 2 types of variable resistors. We have variable resistor, 2 types. The first one, that's number 5, we call it resistant box. Resistant box. It consists of very different values written on the box. In laboratory, you will see what we call resistant box on Saturday and how it can be connected. So, it has 2 terminals. Let me just say, right from cell, there are 2 terminals, positive and negative terminal, red and black. Key has 2 terminals too. Some key they put black and red, some they put the same value. It depends on which leg of the battery connected to the key. If you connect positive to one terminal of the key, that terminal has become positive. It's not necessary that they put positive or negative on the terminal of the key, but it all depends on which leg of the key is connected to which of the terminals. As soon as you connect that terminal to positive, it becomes positive terminal. The other will be negative. Another connection, you connect negative to that terminal, it becomes negative. That means in this circuit, the terminal that is positive in this circuit, another time you connect may be negative. It has no symbol, it has no sign. It depends on which of the side of the key connected to the battery, which side of the battery is connected to it. And battery has positive and negative terminal. So take note of that. Key has 2 terminals which may be connected to either positive or negative. Due to the standard resistor, there are 2 terminals there too, which does not have positive or negative. It depends on which side you connect to side of the battery. If you connect positive side of the battery to this side becomes positive. And if you connect it to negative side of the battery, it becomes negative. But for it, as it is, there is no positive, no negative terminal, but there are 2 terminals on it. The next one is resistant box. The symbol of a resistant box is very similar to that of then you have variable symbol like this, and R is on it. Look at that symbol. The resistant box has this symbol. Anywhere you see this, it's a resistant box, and it's one of the variable resistor. The value of resistant box can be varied. The value of standard cannot be varied. So this symbol shows that you can adjust it. It's adjustable. Resistant box is adjustable. You can adjust it to 1 ohm. If 1 ohm is needed, you can adjust it to 2 ohms. You can adjust it to 3 ohms. But it has to be integer. It can be 1.5 or 2.5. You can adjust it to 1. Integer means whole number. 1 ohms, 2 ohms, 3 ohms, 4 ohms, 5 ohms, 10, 20, and so on. It has to be an integer. Is that taken? So you can vary the values on resistant bulb. Number 6, under the component, I give 6. The 6th one, is rheostat. Rheostat is another component. Rheostat is another type of variable resistor. The resistance can be varied, and the symbol of rheostat is this. The symbol of rheostat is this. You can have this as rheostat, which may be either in series or parallel. This also may be in series or parallel. You have it in series or parallel. Rheostat is number 6. Number 7 will now be the meters. Number 7 the 7th component is ammeter. The symbol of ammeter, as you are taught before, is this. And you are told the position can only be series, no parallel to this one. That's an ammeter. So two terminals, I've explained that to you. Number 8, you also meet in the electricity. The 8th component is voltmeter. We have voltmeter. And the voltmeter will have position or parallel. So I will continue from the 8th component. We see need okay, we need potentiometer, we need meter bridge. So after all these components, you can now join together and we take your reading. So far so good. I will meet you on Saturday to see what you can do.